Okay, hello everybody. Let me make sure we have everything going. Can everybody see the screen that I see? If you can, please respond in the chat. All right. Okay. All right, let's see. Can anybody see my screen at all? Okay, I saw a yes, can see. Okay. All right, so everybody can see my screen. Okay, and I assume you can hear my voice as well. All right, so let's go ahead and begin. We got a lot to cover and short time to get things done. So let's go ahead and get ourselves going here. Minimize you if I can. Okay, now maybe you'll go away. All right, I'm gonna live with that. Okay, there we go. And we're seeing full page now. All right, thank you for everybody who's responded. Okay, good. So today we're going to talk about the second in our series, and that is in the Decoding the Mysteries series. So kind of to give you an idea of where we're at, what we're going to do is historically, last October, we looked at Kjeldahl chemistry. Okay, it was recorded, and I'm going to have a link in the thank you note for the attendance that will have the link to the video that you guys can go back to review. Our second in the series today is understanding your system. We're going to look at user maintenance and DIY, so that way there are things you can do to keep your system running in a good, healthy mode to get you good chemistry. Okay, there's two other series that we're going to break down, and one is for food and dairy, the other's for environment. When you're talking about environmental applications, commonly you're looking at ammonia as well as TKN, and that's a little bit different from looking at food and dairy, where you're principally reporting and looking at protein. Okay, so we've got a few more things that we're going to cover along that line. Once we get to that point, the dates are yet to be determined. One will be in March, if not both of them will be in March of 2018. So the outline of our day today and our time today is going to be pretty straightforward in this regard. Because we are talking about maintenance, we are talking about getting our hands into a system where there are going to be chemicals and where we will most likely need to be doing things with the system energized or have the electricity on. So we're going to have a little brief commentary about safety, something you definitely want to build into any kind of a maintenance program that you build. Okay, and then a user maintenance, whatever. So the next thing that we're going to do is we want to basically tie together the relationship between the physical instrument and the chemistry, and how they are inherently tied together to get you the good quality results that you need for your product labeling and or your reporting for EPA permitting and things along that line, and or other chemical testing. All right, so the four different aspects that we principally are going to cover to make sure that we get good chemistry is digestion, distillation, aspiration, and titration, and how they intertwine with one another to make sure that you get a good fit. And then at the end, we're going to have a general discussion. By all means, send us the questions that you have, and we'll follow up on them. The main thing is we're going to hold off on replying to questions to the end of the presentation, just so that we can keep it simple. It is maintenance. It is kind of a lengthy process to go through and make sure that we have all the little I's dotted and T's crossed. But the one thing we want to do is get the explanations in. So we're going to hold off on the discussion. Any questions that you ask them either in the questions or in the chat, and we'll go from there. And now, so the other thing that we're going to do, and by the way, I just saw a note pop up. I should introduce myself. My name is Jerry Richardson. I'm a market manager for Buki, and my responsibility includes a lot of different things, but for right now, for today, we're talking about Kjeldahl. So another part of what we're looking at today is we're looking at helpful hints. These basically are designed to kind of help to get you to thinking in a way that will help you to maintain your system, keep it running. A little bit of tidbit of detail you may or may not think about while you're doing your maintenance and or working through your system, optimizing, what have you. Okay, so the first helpful hint in that regard is going to be follow a structure. You buy a car and you don't do any maintenance on the car will break down. To keep that car running longer, the best thing you can do is develop a user maintenance plan. Some things you'll do yourself, brakes, oil, things along that line, tires. But some things like any kind of engine or other types of issues, you do want to have a professional look at it. We advocate the same thing, okay? So without further ado, first things first, let me go ahead and go through the safety rather than send that over. What we want to do is make sure you maintain your PPE, personal protective equipment. Wear your gloves, wear your goggles, wear the right clothes, no open toe shoes, things along that line. One thing we have to make sure is, yes, we are working in an environment that could hurt you. There are general safety rules, and by the way, these are sections in each and every one of our operators' manuals, so you'll find these accordingly with the section that's listed in the note and the slide. All right, so be aware, used Buki spare parts, knockoffs, and things like that are really tough to justify. And remember, you are responsible for yourself at a certain point in time. We all want to go home to our families at the end of our day. All right, so a couple of built-in things into each system as well. You have various sensors. Those sensors will tell you whether or not things are working and you're in a safe condition environments. Pay attention to those, work them into your user maintenance protocol. And same thing with the other instrument we're going to look at. The two instruments that we're principally going to look at today are the K375 and the K360. Okay, so with that being said, let me introduce to you Steve Graham. He works within our service department. He's been working with Buki now for probably a decade or more. And he's been working with Kjeldahl chemistry for probably around 30 years. So we're looking for him to pass on some of that knowledge and as well as work with us on the given instrumentation. So Steve, take it away.
Thank you, Jerry. I welcome all of you, and I really enjoy working with Kjeldahl. I've worked with Kjeldahl, as Jerry said, for around 30 years. One of the first questions I want to answer is, yes, it is really spelled Kjeldahl. This is owing to the inventor of the method, Johan Kjeldahl. He worked at the Carlsberg Brewery in Denmark, and in the 1880s, he was tasked with finding a method to look at protein in vegetable matter, such as grains. So he came up with a method for doing this, and we call it the Kjeldahl method. The important thing to know is this was in 1880, and it is still the primary method for nitrogen analysis. In the typical laboratory, you may be running only ammonia, depending on your permit or depending on what you want to do, ammoniacal nitrogen, or you may be running total Kjeldahl nitrogen, or you may be running both. Free nitrogen or ammoniacal nitrogen is basically a two-step process. The sample is preserved with sulfuric acid at a very, very low pH, somewhere below pH of 2. That holds all of the ammonia in the solution. Then we take that solution, we raise the pH in a closed system. We raise the pH to above 9. That releases the gaseous ammonia, and the gaseous ammonia is then distilled and collected by boric acid. That boric acid is then titrated. Similarly, total Kjeldahl nitrogen is exactly the same process, only before we do the distillation process, we actually digest the sample with sulfuric acid and a catalyst into ammonium sulfate, and then the rest of the process is basically the same. We distill the sample, into boric acid, and then we titrate the boric acid. So let's take a look at each of these steps and what is important in these steps. The goal of digestion is to convert all of the nitrogen in the sample into ammonium sulfate. Now, if you're doing ammoniacal nitrogen only, you don't do digestion. However, there are big digestion impacts. When you run a digester, here again, it is important to get good acid contact, good heat contact, and to have the right catalyst in your system to break down all those proteins into ammoniacal nitrogen. The other great thing is, and I really encourage everybody to use this, you should have boiling rods or boiling beads in your process to enhance the boiling of the system and to enhance actually the digestion. When you get through with the digestion, you should end up with a blue, very, very light blue or blue-green sample that is clear. It should not be cloudy, and it certainly should not have any charred or black or brown portions of it. If it does, that's an incomplete digestion. Some of the symptoms or some of the reasons for that incomplete digestion can be the temperature is too low, the temperature is too high, foaming of the sample, or it could result in crystallization of the sample. So let's understand in the digestion process what's involved. Buki has been around Kjeldahl systems and building Kjeldahl digesters since 1960s. And they have refined the process, and even the glass of the sample tubes is important. The design of the Buki glass on the sample tubes is important for sealing for the manifold. The thickness of the glass is important for heat transfer. In this slide, let's take a look at one thing in particular. It's called what we call the safety zone. I call it the reflux zone. On the system, if you'll notice on this slide, on the right side, it shows the safety zone. That's the zone where you're boiling sulfuric acid with your sample should be going up the sides of the glassware, condensing on the sides of the glassware, and falling back into the boiling sample for adequate digestion. The digestion should be, as we said, typically early in the digestion, you will see a lot of cloudy fumes coming up. That is the water being driven off, and it is part of the sulfuric acid called fuming sulfuric acid. At the completion of digestion, here again, all of those fumes should go away, and when you have a finished digestion, you should have a clear or colorless digestate. Here's something that I really advocate. It is not absolutely necessary, especially for ammoniacal systems, but for protein systems or for solids, you really should use either boiling rods or 6mm boiling beads. That's important to promote boiling without bumping and to enhance the digestion process, and they are reusable. So let's take a look at what can go wrong on a digestion. If the sample comes out charred or discolored after digestion, that's very specific. Typically that means that the catalyst that you're using, whichever Kel tabs that you use, should be matched to your sample. Typically if it comes out dark or charred, your sample probably has a little bit more fat or sugar in it than the Kel tab is prescribed for. You can go to doubling the Kel tabs in some suggestions, or changing your Kel tab completely. The next thing is to look at the temperature of the digester. Maybe it was not getting hot enough, and we'll discuss that further. The length of the digestion time possibly was too short. If you're getting charred samples, you need to take a look at these 3 examples, and we'll discuss that further. If the sample is crystallized at the end of the digestion, this is kind of the opposite of the first bullet point. The sample results, if you have a solid at the end of your digestion process, typically that is due to the volume of sulfuric acid is too low, and you make a supersaturated solution which crystallizes. The remedy for this is go back and add 5 more mils of volume of sulfuric acid to each of the digests and redigest the system. Or decrease the digestion time by 10 minutes so that you don't create that crystalline effect. So let's take a look at the digest. On this page, we have our automated digester, and as you can see, the color of the digest, most of the time, depending on the catalyst, is a little bit more blue-green than these. These are very green, but it depends on the catalyst that you're using. But they should be clear, they should be liquid, and they should be green or blue-green. That's a good digest. One of the symptoms that we talked about earlier is not getting enough heat to the actual digestion. This can be, if you have a block digester, this can be due to residues left in the wells of the block digester. If you have a Buki block digester, we have a part number for a digester cleaner. It's a wire brush that's made specifically to clean the wells on our block. You should also check periodically to make sure that your tubes fit snugly into the wells. Okay, when you're taking a look at your block digesting system, you can clean the block with a Scotch-Brite pad. Another place is the heating element may need to be replaced. If everything is clean and everything is fitting well, then there may actually be damage to the block or to the heating element, or the insulation on the frame may be damaged. In all of those cases, you need to get with Buki for a Buki service engineer to do that replacement work. Okay, let's say we have our digestion done and it looks perfect. We're going to move on to the distillation process. What is the goal of distillation? The goal of distillation is very simple. We've just made a bunch of ammonia or ammonium sulfate in our system. And what we want to do is move that ammonium sulfate, which is captured at this point. We want to move that into the ammonia gas form, and then we want to condense it into a collecting solution, or in this case, boric acid. So let's take a look at the K375 in action so that you can see how that process actually works. Okay, that was a great video showing you how the system works. I'm sure you're familiar with the system and working in your lab. Now let's take a look at what the K375 can actually tell us. And we're gonna look at the K375 primarily because that is our current model, and it has many helpful parts in the software that help you diagnose problems or issues. If we go to the home screen, then we can go down to the diagnostic screen and go to the service mode. Now, the next few slides will be in this webinar, and they're primarily for your reference in the future because we did a video of actually running this so that you can see how the diagnostics works. So let's take a look at the actual video of actually running it. Let's take a look at a couple of sensors on our K375 that are related to safety and that they can tell you quite a bit. Here we have, again, the home screen. We're going to go to diagnostics. We're going to go to service mode. We are going to say yes. And here we are going to look at the sensors and switches. In the sensors and switches screen, we have a number of sensors. If I open this door for the sample tube, you can tell that the shield sensor has gone gray rather than green. If I take the sample tube off, the sample tube sensor has gone gray rather than green. We'll come back to the sample tube sensor in a few moments. Okay, that was an example of our diagnostic screens in the K375. We also have diagnostic screens in the K360, which is also our current sample, or our current system, excuse me. And we will have a video, a similar video for those diagnostic screens. But in this webinar, you can use the following slides to go through the diagnostic screens just like I did on the K375. Okay, a very common error that we receive a lot of calls about is no sample tube present, both on the K360 and the 375. Now, you can see that the sample tube is on the system and latched into the system, but you get a no sample tube present error. This is quite common. What has happened is the adjustment of the sample tube in relationship to the sensor has moved somewhat, and it's a very simple process on the K375 to adjust this so that it does take care of the problem. We're going to take a look at a video where we are going to adjust that sample tube sensor to remedy this. The sensor for the sample tube. Quite often, we have customers that call us and say, we have the sample tube on the system, but I'm getting an error saying the sample tube is not on the system. Obviously, I can see that the sample tube is on the system. So the reason for that is the actual sensor for the sample tube. If we take a look, if you have a sample tube on your system and you get a no sample present or no sample tube present error, what you need to do is loosen these two screws and run this up just a little bit so that it is tighter to the system. What that does is change the sensor location so that it sees the sample tube on the system. Okay, there will also be a similar video on the K360. It's a little bit different process on the K360 to adjust the sample tube error sensor, but we can take care of that. Another common error that we find is cooling water flow. This can be due to two distinct processes. One, obviously, have you turned on the cooling water? I know that's rather obvious, but there has been times when it has been an issue. The next question is, do you have adequate flow rate of your cooling water? The flow rate that it has to see on the system is 0.6 liters per minute. There's two reasons why the flow rate may be in error. One is a very simple fix. Turn off your cooling water, go to the back of the instrument where the cooling water inlet is, unhook the cooling water inlet, and you will find a screen on the back of the instrument where that cooling water comes into this system. If you're using tap water, this is quite common after many years of use, that you need to clean that screen off so that you do get adequate flow. The other reason you'll get this error can be the outflow sensor that actually looks at the flow rate. If that is in error, then the best policy is to call Buki service and let us replace it. For those of you that have the K375 and using it with the Autosampler, the K376, you may also find a sample tube not found error. Now, this isn't on the distillation system. This is on the Autosampler system. On the Autosampler, that's a very typical issue to find if the wave spring has been misaligned or worn out on the sample tube arm. In the following pictures, in this picture, we're seeing the actual sample tube and the wave spring at the bottom of the sample tube. On the next picture, we're looking up at the bottom of the sample tube arm. And this is a very simple process to change this wave spring. In fact, it is in the operation manual as a routine maintenance part. But the key here is to make sure that you get one of the spring members on that sensor spring that is depicted by the red arrow in this picture. Be sure to get it right there and you'll be good. Okay, let's move on to steam generator issues. There's a lot of interesting reasons for steam generators issues, and we can diagnose many of them. You can diagnose those yourself in many cases. This is an image of the steam generator by itself. Now I want to draw your attention to three areas: the drain outlet, the drain valve, and the thermal safety switch. These are areas that will help you determine or diagnose the problems that can be associated with the steam generator. If you get a steam generator issue, one of the things that you can do is you can turn off the system, turn it off and let it cool down. Remember, we're dealing with very, very hot water. It's steam. Do not do the following procedure until it's cool. I prefer to let it cool overnight, but 2 or 3 hours is good. Anyway, one of the diagnostics is to connect a tube to the drain outlet, as indicated on the image with a red arrow. Open the drain valve and put the other end of the tube in a beaker. What you should see is about 300 milliliters of water drained out of the steam generator. If it does not, then there's a problem with the water going into the steam generator. After you do this, close the drain valve and turn the system back on and listen to the system. What you should hear when you turn the system back on is the water pump should be activated and it should be filling the steam generator. If you do not hear the activation of the water pump, then it's highly likely that the water pump itself is bad or the water pump fuse has blown, in which case you need to call Buki and we can replace that water pump for you and you'll be back up and running. On very, very rare occasions, if it does, when you turn the system back on and it does, if you can't hear the water pump running, that could indicate the internal float valve may be malfunctioning, the thermal safety switch may have failed, or the heating element itself may have failed. All of these should be referred to Buki service for remedies. Okay, so let's say everything is working great. The first thing you're going to do to have a great system is you're going to use the preheat function on the system. What this does for you is it heats up the two circled seals in this image. Those two seals are critical to getting good results. Here's another one of our helpful hints. The preheat cycle, always run the preheat cycle on your system before running samples. Okay, why would we get improper or poor distillation? I would say 80% of the time it's because of leaks at those seals. So run the preheat, make sure the seals are heated up and sealing. You may also get leaks at the aspiration vessel inside the cabinet, and we'll address that in a video a little bit later. You may be getting improper dilution with the water. The water pump may be not working correctly. You could also get poor alkylation. The sodium hydroxide pump may not be working correctly. Here again, we'll address that when we talk about the calibration of the pumps. You may have a low boric acid volume for the receiver. Here again, that's a pump issue that we'll address when we talk about calibration of the pumps. Or you may have a low volume of distillate. Let's take a moment and do a very simple diagnostic that you should put in your system. I would highly recommend putting in a method that is called distillate check or distillate volume. Every one of our systems, if you put this method in, basically the method is a distillation, a 5-minute distillation with no added water, sodium hydroxide, or boric acid. It's simply a 5-minute distillation at 100% steam output. You collect that distillate and you measure it. If it is less than 130 mils, then you have a leak somewhere in the system. So, what if I discover that I have leaks in the system? Where should I look for leaks? Okay, the sample tube connection, which is the lower circle on this image, that should be replaced on a routine basis. If you have an annual PM service contract, we replace that. but it's also a very simple thing to find out, should I replace that? Okay, let's go to the next slide here. Okay, we'll have a video that shows this better, but basically all you need to do is have a cool sample tube on the system and twist it to find out if you should replace the bung. If you can twist the sample tube easily, you should replace it. When you replace the bung, you need to replace the hypalon in the splash guard at the same time. The other seal to make sure that you check is the condenser to splash guard seal. And please use our tool to tighten this seal. The part number is here on this slide. Please order one. If you don't have one, please do not use a pair of pliers on this fitting. All it does is break the plastic fitting or break the glass. Now let's take a look at the video explaining the outside of the cabinet, on the face of the cabinet, these seals. Of the cabinet. We have our safety shields that we're going to open. That gives us access to two very important parts and two very important seals on the instrument. The first is up here. This is the seal between the condenser and the splash guard. This is probably the most likely reason why your nitrogen levels could be low. When the ammonia is evolved, it goes up here and leaks right out of here. To remedy that, always use the tool for tightening that. This is a very simple tool that goes right on there and tighten that down. If you see any drips coming off of here, you are losing nitrogen right there. So make sure that is always tight. Do not use pliers. That will only result in breaking the plastic nut or the glass. The next area is the sample bung and the sample tube. This area, I'll take this off, this rubber bung should be replaced when it's worn. And you ask yourself, how do I know if it's worn? It's a very, very simple test. Do yourself a favor. Every once in a while, with a cold tube, just put the tube on and grab it and try to twist it. If it twists easily, that sample bung needs to be replaced. If it's nice and tight, you have a good seal. There is another aspect of the sample bung to the bottom of the condenser tube. You use this tool to tighten that fitting at that point. That's very rare that that's a problem. This is very common to have a problem. And those are the seals on the front of the K375. Okay. The next issue that we want to take a look at, I mentioned previously, is what if the water pump, the sodium hydroxide pump, or the boric acid pump is not calibrated or not delivering the right amount? It's a very simple thing. You should put this into your routine maintenance. You go to the home screen, go to system preparation and pump calibration, and you run the pump calibration for each pump. After that runs, you will have an amount of liquid that it's going to dispense depending on the pump, and you're going to put that in a graduated cylinder and put that volume in the system and it will calibrate the pump as necessary. I believe most of our customers are very familiar with calibration of the pumps. I would suggest doing that about once a month. It's a very simple process to do. What we've depicted here is the K375. You also do the same operation on the K360. Follow the prompts on the screen. It's a very simple thing to do and a very helpful diagnostic for you. Okay, so we just discussed the distillation performance due to the pump calibration. Here we go. The water dilution, if it's too much, it can stall the reaction in the sample tube. Typically, you're going to use 50 mils of water for your sample. At 32% sodium hydroxide, typically you're going to use 60 to 80 mils of sodium hydroxide. That makes the sample up to above pH 9. And on the boric acid, here's a very interesting part. On the boric acid, you need to make sure that if you're using a pH probe, that the end of the pH probe is not touching the bottom of the distillation vessel, or the receiver vessel. And you may need to make sure that the bulb is covered by the boric acid. This is typically about 50 mils. If you're running colorimetric analysis, again, you need to make sure that the bottom of the probe is not touching the bottom of the receiving vessel and that it's covered for the entire length of the screen. This is commonly a little bit more, about 60 mils of boric acid is needed for that. Remember that only water and those compounds with boiling points of less than 100 degrees C will come over into the receiving vessel. Okay, let's talk about inadequate distillation in relationship to incomplete aspiration. I'm sure many of you have experienced times when the aspiration of the sample tube or the aspiration of the receiving vessel has not been complete. This is almost always due to a leak at one of the seals that we've previously talked about, or at one of the seals that we are going to talk about on the inside of the system. Aspiration on our system is completely controlled by vacuum. Therefore, any leak is going to affect the aspiration. So here again, we've already talked about the seals on the outside. Let's take a look at some of the seals on the inside. On the inside of the door of your system, there's several seals that are critical. I've highlighted those in with red arrows. It's a little bit difficult to see all of the seals, but there's typically one or maybe two seals on the top or the bottom of the aspiration vessel. And we're going to take a look at the video to see which seals we're going to look at and pay attention to. Now that we've seen how to tighten the seals on the front of the cabinet, let's take a look at the seals on the inside of the cabinet. I have opened the cabinet door. There is no reason to power down for this part of the maintenance. However, there's very important seals inside the cabinet that need to be addressed. These seals are addressed using your tool that we used on the front. This is the SVL22 tool. You simply put it on these black fittings on the top of the aspiration vessel and on the bottom of the aspiration vessel and at the very top on the aspiration valve. The other seal that's very important is located at the back of the splash guard connected to this T. It's not easy to see that on this video, but it's very apparent when you open it up. There's a seal back here at the back of the splash guard connected to this T. All of those need to be nice and tight. Okay, so on the K375, we're just going to go through a little exercise real quick. If you're having problems with aspiration, this slide shows a depiction of how to go through and use the diagnostics on the software to diagnose problems with the aspiration. What we'd like to do is use a video to actually show you how that is accomplished. So on the system, here again, we go through the diagnostics mode, and we're going to turn on and off that aspiration valve. So let's see what the K375 software looks like on the instrument. Here we are on the home screen. We're going to go down here to the diagnostics tool. From diagnostics, we're going to go to service mode. In service mode, we have to tell it, yes, we really do want to run in service mode. At that point, we have access to all of these different parts of the instrument. We're going to look at the valves section. In the valve section, what we're interested in is the aspiration valve, and you can turn it on and off and listen for the click of the solenoid. Okay, so basically we have the same sort of diagnostics tool on the K360. The important lesson in this is go to the diagnostics, turn the valve on and off. If you do not hear it click, then the valve needs to be replaced. If you do hear it click, then most of the time the valve is just fine. So that's a little diagnostic routine that you can do yourself. One of those very interesting things, if you're doing TKN and you're using boiling chips, we see this quite often. If you're using boiling chips, the smaller boiling chips can be aspirated up into the system when you do aspiration, and they can be lodged in the valve, which will cause the valve to malfunction. What you need to do is you do need to use boiling aids, but you need to use a boiling rod or a boiling bead bigger than 6 millimeter. Okay, so step 3 in this process is titration. We have distilled the sample. Now it's time to get some results from all of this. Basically, titration is after we have received the ammonia into the boric acid, that makes a compound called ammonium borate, which increases in pH, and then we're going to titrate that with a known concentration of sulfuric acid or hydrochloric acid to determine the actual results. One of those, obviously, if you're using a pH probe, a very important aspect of this is to calibrate that pH probe. This should be done. It's a very simple process on the K375 and the K360 to calibrate the pH probe. You go to the home screen, go to the system sample preparation. We have calibrate pH probe. You click it and it takes you through the process to calibrate this. Calibration of the pH probe should be done on a daily basis. We suggest that in our manual. You may have even a more frequent SOP in your laboratory, but it should be done on a daily basis. It only takes a few seconds, very simple. Speaking of pH probes, it's very important if you have a liquid junction probe that you keep that probe in potassium chloride solution when it's not being used. Do not leave it out in the air. That's a really bad idea that will make the junction very slow, very sluggish. Put it in potassium chloride solution for long-term and short-term, even overnight. Rinse it with DI water, and rather than wiping the bulb dry, try shaking the excess water off of it. So, because wiping it can abrade the surface and cause problems. Always, when you're doing calibration, always use fresh calibration solutions. Rinse the pH probe between each calibration solution and shake the water off of it. Okay, another helpful hint that we're going to talk about is highlighted in the K375 by the chart display. The chart display gives us a real-time pH of what the system is doing at any given time. This is really, really beneficial for not only monitoring the system itself, but also coming up with a better method for your particular samples called method development. We may need to change some of the parts of the method to accommodate your samples. Okay, another helpful hint on this, to optimize your process. It's really important to use verification substances to optimize your process. That way we can isolate the distillation process from the digestion process. We can also take a look at your laboratory practices, making sure that you have nitrogen-free boats to weigh into, and how you transfer the sample to the system, and rinsing that sample down into the sample tube after you've transferred it. Okay, the reference substances that are generally used for verification are as follows. We have two different sets of reference substances. Ammonium dihydrogen phosphate and ammonium sulfate are used to look at nitrogen, or the ammonia end of this equation. That does not need to be digested. We simply put it in the tube, add some water, and then run the ammonia on it, and we should get a verified percentage of ammonia, and we're going to compare that later so that we can verify the system is running correctly. Likewise, glycine and phenylalanine are used to digest as a digestion type system. These are not readily available dissolved in water, so you do have to digest those. Why do we do this? Because if you're using a TKN solution to your analysis, we need to look at, is the digestion process working correctly? If the digestion process is working correctly, is the titration process working correctly? So it's very important that we can narrow down an issue using two different verification substances. Okay, Now that we've verified that the system is working perfect, holy moly, I've got low ammonia. This is a very typical thing to have happen. My ammonia is too low. It's a very typical response. What happens? You have a leak in the system. 99% of the time, there is a leak in your system, typically between the splash guard and the condenser connection. I think we've gone over those connections a couple of times, but that is typically where you are going to have a leak in the system. And if the leak is severe enough, your low ammonia results will be accompanied by the aspiration problems that we've talked about earlier. There are other reasons for low nitrogen that I want to discuss also. One of those reasons is you may have the pH of the boric acid may have not been adjusted correctly. That's a very typical reason why your pH will be, or your results will be low. The accepted standard method is to adjust the pH of the boric acid to 4.65. Be sure that you adjust the pH of the boric acid after you add the indicator to the system. If you purchase boric acid, either 2% or 4%, from a reagent vendor, be sure that you standardize to 4.65. If the pH of the boric acid is lower than 4.65, your results will be lower also. Another reason, be sure and verify the concentration of your titrant. I have had many occasions when the customer thought they were using 0.1 molar sulfuric acid when they were actually using 0.2 molar sulfuric acid. So just verify the concentration of your titrant by independent titration. Again, we visit pH probe calibration. If you run the pH probe calibration on a daily basis, you should have no problems there. After completing all these procedures, run the verification substance again. If you still have a problem with low nitrogen, you need to call us at Buki Service and we'll do further investigations with you. Just like low ammonia, you may have low TKN results. Obviously, if your ammonia on your distillation system is running just fine, but your TKN results run low, there's a problem with your digestion. If you believe that there's a problem with your digestion, you may need to increase the volume of your sulfuric acid just a little bit by 5 mils and redigest your samples if you're getting crystallization. I believe we have discussed this before. The result of a crystallized sample is always going to be low. After completing the procedures above and for ammonia, rerun your digested verification substance. If it's still low, give us a call at Buki Service for further investigation. High ammonia results. Now this is a little bit less likely. It's typically due to the boric acid pH not being adjusted correctly. Here again, if your boric acid is supposed to be 4.65 and your pH on the boric acid is actually 5.0, it's going to take longer to titrate that, and that's going to result in a higher than realistic concentration of nitrogen. Again, go through the pH probe calibration as we've discussed before. Sometimes, and a very, very few times, there may be contamination from your water or your sulfuric acid. Try reducing the amount of water or increasing the amount of water in your sample. That may show you that that will increase or decrease in relationship to that ratio. After completing all the procedures above, here again, run another verification substance. And if it's still too high, call Buki service for further investigation. On TKN, on very rare occasions, I have come across contamination of the sulfuric acid. This is easy to diagnose. Vary the sulfuric acid in a digest of your blanks. Put 10 mils, 15 mils, and 20 mils in a blank and do this digestion. Then run the sample. Obviously, if there is contamination of your sulfuric acid, that contamination will vary with the ratio of the acid that you've put in. Again, after completing all the procedures above, if you still have a problem with high TKN, please give us a call and we will certainly help you. There can be Burette issues on the titration end of things. The typical issue is bubbles in the Burette. If you're having issues with low or sporadic nitrogen content, take a look at the Burette tubing going over to the receiver flask. Make sure all of the lines are tight and the lines going to the dispenser tubes are tight and the acid bottle are tight. If you see bubbles in the Burette, go ahead and redispense from that Burette to try to rid those bubbles. On occasion, we have seen a problem with the diffuser tip at the end of the Burette. Here again, it's a simple thing to replace that diffuser tip, and it should be replaced during our annual PM. We do have several reference materials to help you along your way. We have a product called the Kjeldahl Practice Guide that you can contact us to receive. It comes with a new system, with a new distillation system. We also have online the Buki Kjeldahl Knowledge Base, and you can see the URL down at the bottom of the screen that you can go to, register online, and it opens up a huge database for all of the knowledge that we have on Kjeldahl systems. I thank you for your attention. I'm going to give it back over to Jerry at this point, but I have to tell you, the best preventive maintenance for your system and the best way to keep it on a high performance is to use a routine maintenance program and to call Buki Service annually for a preventive maintenance agreement.
Okay, thanks guys. We're going to go ahead and open up the floor here in just a moment. As you can imagine, this is principally an overview of what we could do within an hour's worth of time, if you will, and make sure that we don't bore people to death. But the main thing is we really want to emphasize that what we do is we want to keep you guys running at an optimum level. And the best way to do that is to help yourself. Report to us. Buki does not charge for conversation. Call us, email us, whatever you need to do. But the one thing you want to do is get yourself on a maintenance schedule. It will make all the difference in the world in your success, and you'll be very happy that you did. Okay? All right, so let's see about some questions.
Well, okay. Let's see. The first question that I see is the tube not present error. I did go over this earlier, but that's quite a common question. If you receive the tube not present error, that is excuse me, typically due to the sensor being out of alignment with the sample tube. So back on slide 30, we kind of went over how to adjust that sample tube sensor so that you can remedy that error. Also, okay. We also have a question about, I see steam coming from the fitting around the condenser. I'm assuming at the top of the condenser is what you're talking about. At the top of the condenser, that is the fitting between the condenser and the splash guard, and that has a Teflon seal held in with that black plastic nut. Here again, we went over how to use the Buki tool to tighten that nut so that it does not leak. You got another one there? Let's see. Would solutions, I'm sorry, I can't see very well.
I'll read it for you.
Thank
Would
you.
solutions too low non-protein nitrogen be similar to low ammonia or TKN?
With solutions too low non-protein nitrogen, yeah, non-protein nitrogen is going to refer to a non-digested nitrogen. So you're talking about nitrates in the sample, that sort of thing. But the same remedy applies. If your non-protein nitrogen is running too low, then you're losing that somewhere, and it's typically due to a leaking seal. Okay. Here's a question about some of my samples are being crystallized at the end of digestion. Okay. Well, here again, that is typically due to not enough sulfuric acid added to your digestion, or too long of a digestion routine. So I can't tell you which one it is, but if you're getting crystallized samples at the end of digestion, go back and add 5 mils more sulfuric acid when you digest the samples, redigest them and see if that resolves the issue. If it does not, then you need to subtract 10 minutes from your digestion time. Okay, do we have more questions?
All I see is a fun little comment. Okay, here we go. There's another one.
You'll have to read it.
Okay.
I'm old, I can't see.
Understood. We've been getting an error of pH is too low on NPN.
Sure. Okay. The first thing you should do is check the pH of your boric acid. Do that and adjust the pH of your boric acid to 4.65. That is another one of those very common questions, and that typically alleviates the problem.
Okay.
Any other questions? Feel free to ask anything that you want to.
Okay. So 4.65 on the pH on the BA is important for NPN too.
Absolutely, because the standard method titrates to 4.65. If you start below 4.65, you will get the error message, pH too low. So when your boric acid goes into the receiving flask, it needs to see 4.65.
Just one quick thing to add to that. I've also seen where people are dispensing the boric acid directly into the receiver vessel. Well, commonly what you'll see is a little bit of residual moisture or water that's in the receiving vessel, and that can actually change your pH. So when you're actually doing your preparation of the boric acid, the one thing you'll want to do is decant specifically into a clean, dry container and measure that. That way you're getting no influence from an outside perspective, and you won't get the pH too low issue returning.
Yeah, that's true. Mm-hmm.
Okay. All right. I saw one more pop up. Let's see what that is. Okay. Any suggestions for the Buki 323?
Yes, I have a suggestion for you. Buy a K375 or a K360. Actually, I'm glad that you asked that. Anybody that is listening that has a B324 or especially a B323, you must remember that we no longer have parts for those systems. If something goes wrong, we cannot fix the system. So put it in your budget to buy a 360 or a 375. However, with all that being said, the same exact things that we've talked about here apply to every Kjeldahl system that Buki makes. If you have a leak between the condenser and the splash guard, it's the same condenser and splash guard on the B323 and 324. So if you are having problems, look at those same areas. The same principles apply to all of the distillation systems.
Okay, we can talk with you guys about the models that are more than 10 years since discontinuation, but we do not have parts and we actually cannot come out and help to service them anymore. We just don't have them anymore, quite frankly. But the one thing we can do is recommend that those same physical connections, by all means, you can go through the video and you'll see the different connections. They still apply even to older models. Okay, they may not be the exact kind type, but if you've got a leak here, it's a leak wherever. Okay,
yeah, absolutely. Yeah, we're here to help you. Even if you have a way outdated system, give us a call. We may have, one of us may have a part that's squirreled away. I can tell you this, that on the 323 and the 324, there are no more electronic parts. We have glassware. We have a few valves left, maybe, but the motherboard, the display boards, there are no more.
Okay, so the K370, it's showing that that's also a discontinued model as of 2012, but we still do support the K370. There are still parts available, and there are still electronic parts as well. So if you need service on a K370, we can assist you with that. That's still well within our...
Oh, yeah. Yeah, I do PMs. I'll do a PM next week on a K370.
And I think it's Jennifer you're going to go see.
Oh, sure. Yeah. Same here again. All of these things we've talked about, with the exception of specific software items, all of these principles are the same no matter what instruments you have.
Okay. And keep in mind, all these things that we've been discussing as well are in the maintenance section of your manual. There's a few little things here and there, little tips and tricks that we're giving you, but for the most part, if you really want to build yourself a maintenance program, you can easily do so by going to the user maintenance section of your manual, operation manual. And if you want assistance in talking it through, working it through, making sure you're not missing something, by all means, let us know. Okay.
Any other questions?
All right. Well, I want to thank everybody for staying. Enjoy the rest of your day. And as we move forward, we're going to send this to you, a link to you, a thank you note, and also have you a link to the first video. So that way you have access to all the things that we have in the series, and be looking forward to the next series of webinars to wrap up this entire set. And they are going to be separated for environmental and food and feed. Thank you, everyone, and have a nice afternoon.
Thank you.
I want to thank Steve for his time. and involvement.
Okay, did you do install?